In this exercise we're given a graph, and this happens to be a closed curve. As theta goes from 0 to 2 pi, it goes around once counterclockwise, and we want not the whole area inside this curve, just the bit to the left of the y-axis. Now I'll give you an idea of what this looks like. I brought in a picture which we could live without, but just to make it more interesting. In general, when we have a plus b, or rather b plus a cosine theta, depending on the values of these numbers, we get different types of curves. But in our case, it would look something like this. If you look at the conditions on b and a, this is the it's a limison, and it's the dimpled variety. But to the left of the y-axis, let me shade that. That is the bit I just shaded. And as far as theta goes, this is where theta is equal to 90 degrees, pi over 2. And then we continue with theta up to the negative y-axis, where theta is 3 pi over 2. So this is these are the limits that we have for the angle, and we just have to use the formula now for area, and the area is 1/2 the integral of r squared d theta, and in our case from pi over 2 to 3 pi over 2. Now we substitute r as this, so we get